Американская фирма Transceptor Technology приступила к производству компьютеров «Персональный спутник». Путник.
Okay, keep cranking. Keep cranking. comm going 10-8. 10-8. Still not working. Keep cranking. Faster. Faster. Crank. Crank. comm going 10-8. Still not working. Keep cranking. Alright guys, let's talk about outdoor electronics. Whether it be bug out electronics, bugging in electronics, or in my case, more than likely it's recreational electronics. What you see here in front of you is typical stuff that you may bring out to the field, whether you're in those types of scenarios. Bugging in, bugging out, disaster, especially disaster, that's more realistic, believe it or not. And recreation, if you go camping or hiking in my case. And this is typically the stuff you might have with you. Like in my case, a video camera to do YouTube videos. Comms for the obvious, information, gathering information, transmitting, and all that other good stuff. More advanced comms over here, meaning smartphone, flip phone. I still rock the flip phone, and a tablet, kid's tablet. Hey, miss.
I like these earrings.
Ah, cool.
I got new earrings.
And a GPS. All this stuff is actually luxuries. This is more, in my case, a recreational loadout. I wouldn't take this or that, but I'll slim this down in a bit as I go through this video. And we're talking about how to power all this stuff out in the field. SurvivalTechNord really sparked an interest in me getting my act together and getting my power requirements met out there in the field, because none of this stuff here is going to work if I can't power it out in the field. Plain and simple. And without reliable power source or a way of getting power source, all this is just dead weight, literally. So this right here is more likely a car camping scenario, possibly, I don't know, but you're outfitted to the hilt with gear, and as you can see, you're just, you know, overloaded with stuff. If this was recreational stuff for me, going hiking to a location, fishing or whatever, this is all I'm going to bring. A GPS, video camera, comms, and my cell phone, and my flashlight here. That's all I'm going to bring, along with the stuff to power that stuff up. So let's go through a progression of sort of domestic shit hit the fan scenario. Let's say a natural disaster, forest fires coming through, and it takes out the electricity. The power poles are all burnt up and shorted out. You lose power. That means this wall wart here is not going to be good for this tablet anymore. So that's taken out. Okay, this power cord that goes to this AA nickel metal hydride battery charger goes away, because we don't need this no more. This charger for the camera battery doesn't work anymore, but it does have a 12 DC volt sort of battery port adapted to it, so the 110 battery thing is not working on this, but this will. So now I'm really regulated to possibly your car battery or deep cycle battery or something like that. And this is a representation of it right here. 12 volts. Let's say you're going to have to hit the road, go hiking, or bug in if you're away from your home or something. You're not gonna be lugging this back home with you. This right here weighs 21 pounds. That's almost 3/4 your pack weight, if you really think about it. So that is not practical to take with you to power all this stuff up. So let's slim this down even further. I'm not going to bring a tablet with me. That's just not my thing. So that goes out. I don't have a smartphone. Maybe later on I will, because that smartphone there could encompass both the phone, the GPS, and a camera. But right now I don't own one. This is my wife's. So I'm still rocking the flip phone. Comms, I'm going to stay with the VX7R. Camera and GPS. Now this big old thing here is not going to be used because I'm not going to be hauling this thing here. So that's going to go. Now I'm down to this setup here. Basic communications with Ma Bell. GPS to record my progress or lack of progress, or statistics, and also a safety backup. Still going to lug a compass with a map, but this is just for statistics when I go hiking and stuff, as far as my speed and, you know, or lack of. Camera to record YouTube videos, and two-way radio, and a flashlight. So here's some further boiling down of my power requirements. The GPS, I'm going to use a lithium-ion battery, and it's charged by 5 volts USB, your computer power source or whatever. Now we're going to get into standards. Your basically your lowest common denominator, which is 5 volts USB and 12 volts car battery voltage. Those are the two voltages that you should be concerned about. Further standardization, I'm only using AA batteries, and I've taken the recommendation of SurvivalTechNord, since he did the legwork and homework on this, and went with the Sanyo nickel metal hydride 2700 amp hour batteries. He's saying that's the best, and that's what I'm going to get. And it is one of the highest capacity batteries out there for AA's, so that'll give me more gas in my gas tank, if you will. So that's powering my flashlight. This is a single battery flashlight, a Phoenix E12, really small, really light. You can't put AA's in this, but you'll use the rechargeable battery in there, and you use the USB connection here to charge this. 5 volts to charge this. In this camera, the same thing, lithium rechargeable batteries, and it takes 5 volts USB port power to power this camera up and to recharge it. The only difference is the Yaesu VX7R. It requires 7.5 volts, and this here it's a 12 volt car battery adapter, and within the little casing here there's a power supply that takes that 12 volts and steps it down to 7.5 volts, and then it feeds it into the radio here through this port right here, and through this port right here it will recharge my lithium ion battery again, so it'll charge this battery. And then as a backup, I can't find my original clamshell, but I have a clamshell that holds 2 AA batteries to supply power to this if I need to. So this has 3 ways of being powered up. The original battery, with this off, I can still power this radio with the carport charger. I can just plug it in, it'll power up that way, and it'll be full power. And then my ultimate backup, or my last ditch resort, will be the clamshell that has the 2 batteries. But the only problem is with only 2 batteries, it only providing somewhere around 3 volts, it's going to reduce the transmit power of this radio by at least half, and then the running capacity of this. And this of course is 1 AA battery, and then I have my charger to charge up the 4 AA batteries that I'm gonna supply all these to. So this is the ultimate backup to that device, GPS, my 2-way radio, and my flashlight. I'm not going to use this particular charger. This is a smart charger. I found one even better. I kind of screwed up the specs on this, so I got something less than what I needed. So I'm going to have a 4-port charger with a USB output as well to be even more redundancy within a device. I'm still charging my AA batteries. Then again, I got redundancy there. All this is pretty much redundant, a circle of redundancy right here. This could charge all these other batteries here, and when I get the other charger, all these other devices here. So this is the device I'm going to use to power all these other equipment up. This is a portable power pack. It's got 1200 milliamp hours of capacity. This could produce 12 volts right there, and also 2 extra ports for 5 volts. So remember the standardization of the least common denominator of all these devices. Some of these work off of 5 volts and some of these work off of 12 volts. This device does it both. So I have 2 ports there, and they both could source 2.1 amps of current on these. If you spec out some of the other chargers out there, or battery banks, they only go up to 1 amp. That could or could not be enough for you. If you're going to power up or recharge a tablet or a little laptop or some of those devices and stuff, you may need more output power. So if your machine sucks up 2 amps of current to charge up your tablet, and you only have a device that sources 1 amp, it's going to take you twice as long to recharge that tablet. But I don't take a tablet out to the field. This is all I carry here. So all these devices, I already measure them. They recharge at less than 1 amp. So this is somewhat, I wouldn't say overkill, but I have the capabilities if I want it. And this is more than capable. This will provide everything that these devices demand as far as current. So here's the first device hooked up, the GPS. It's on right now, and as you can see, it's charging. This battery that I have in here is halfway dead, and it's using up 560 milliamps of current. And this could source 2100 milliamps of current. So this is well below the output of this device here. And if you have a goal 0 or something like that, something that provides 1 amp, you're way below the requirements there. So you're not going to overdrive your source here, or not use the full capacity of that system. You're not shortchanging yourself. You're not on a short leash. But if you had a tablet that was asking more than 1 amp on those devices, then yeah, you're shortchanging yourself. You're pretty much bottlenecking all that current to only 1 amp. So you're going to take a little bit longer to recharge your devices. This here is the same amount of current that would be if you were hooked up into a car battery or commercial wall power, 110 AC. So this is running at full capacity. Now let's hook up the camera and see how much that's drawing. So here I have the GPS and the camera hooked up to the device. So the GPS is charging up, and the camera is drawing 660 milliamps of current, way below, a little bit below 1 amp, and it's charging. And that's the amount of current that draws from a wall outlet as well. So there is no bottlenecking or governing of current being fed into the camera. You're getting the full amount of demand that this thing wants. So here the radio is on. It's hooked up this side charger here, and is drawing roughly 300 milliamps of current off of this machine, but it's 12 volts. So it's more power than these two devices put together. The wattage of this being used is greater than the other two devices. and the little power pack is handling that. So right now I have 3 devices hooked up to this. The radio, which is on, GPS, and the camera recharging, and it is actually asking more demand from the power pack. It went up to 940 milliamps of current, almost an amp. For whatever reason this goes any higher, let's say 1.2, this could handle it because the 2 USB ports are rated to go up to 2.1 amps of current, where some of your other power packs, if you look at the specification, it only goes up to 1 amp. So this will not be bottlenecked into, you know, its full capacity. So at this point I kind of ran out of ports to use to recharge this other devices, but in reality when you're out in the field, none of this devices is going to deplete at the same time, so you could charge one device at a time depending on your usage and your priority of things. Me personally, I want my comms to be topped off every time, and the GPS. Everything else is a luxury, like the camera. So my flip phone there is demanding roughly 300 milliamps of current from the charger here, and this is 300 milliamps at 5 volts USB port power, again with the standardization there, and this is able to produce that, and so will your Goal Zero equipment. I'm mentioning Goal Zero because that seems to be the favorite poster boy of outdoor power regeneration and supplies. My AA nickel metal hydride battery charger here is drawing roughly 270 milliamps of current, and it's using a 12 volt power port to supply that to this device here. So all in all, except for this device here, the GPS, the camera, and the comms, this is able to provide power to all those devices 2.5 times on one charge on this here before I have to recharge the power pack itself. And the power pack in the field, what I plan to hook up to that will be a solar panel, but not this one specifically. It will be one of those foldable solar panels, and it's not going to be Goal Zero. This one here is nominally 10 amps in normal operation like this here. This could power up a portable base station, a man pack radio, and quite a bit of other equipment too. Just using this device here. How long it's going to last, I don't know. I haven't determined what the capacity of the 12 volt battery in here is. I may do that in the next video when I size up and pair up a foldable solar panel with this device here. That's later on. And there will be quite a bit of modifications, like this connector here. I know the nomenclature of this connector. Going to buy a few and make my own custom made sort of cable, so we won't have none of this stuff here. I mean, I don't want this set up in my backpack. It's not stable. It will short out and all sorts of other nonsense. This is going to be changed out, the charger that is. It's going to change it dramatically, but this is pretty much the prototype of the stuff that I'm going to take out to the field as far as electronics. Just the basics. And this is luxury for me. And then a backup for all these devices as far as batteries. I could put AA's in this. I could put AA's in this radio here. And this takes AA's. And this also has, and the other device that I'm going to get with it, has a USB port where I could use this charger to charge this device, my phone, and my camera. And then the solar panel that I'm getting, it also has a built-in 5 volt 2.1 amp USB connector there. So in reality I will have 1, 2, 3, 4 USB ports to charge up my devices during the day, or if I have it on my back, or if I'm just taking a break during the day. So in reality, at the same time, I could charge up this device with the solar panel. In turn, it will power up these two devices here. The 12 volt coming out of here will power up my nickel metal hydride batteries. So that's pretty much what it boils down to, and it's going to get a little bit leaner than this. Like I said, this is going to go away. I'm going to streamline this with some modifications and some wiring on my own. So overall, in my most humble opinion, this setup right here is a more than capable setup with multiple redundancies on how to power up all this stuff to have a pretty nice, comfortable, recreational time out in the woods, or camping, or what do you call it, a picnic, or what have you. For me personally, this is my setup. For right now, it's a hodgepodge of stuff that I just got, and I have to put this all together, but I got the main idea down packed, and we just got to make it field proof in a way. Overall, all this stuff here right now, as you see, it weighs 3 pounds and 14 ounces, almost 4 pounds. This is luxury. A lot of this stuff is luxury. Let me take away what we need for survival, period. Worst case scenario, in my opinion. I don't know. I mean, this is what I think what's going to happen. So I may be wrong, or who knows. Cell towers will be out of the play. So this guy goes. They might take the GPSs offline. This is out. I'm not going to be filming anything. Maybe or maybe not, but this really doesn't weigh much, so I'll leave that here. I'm always going to use the light. I would always have my comm. I would need a power source to power up all these other devices, and batteries for my flashlight here, or back up to that. So let's weigh all this and see what it comes out. I boiled it down even further to the things that I would want if shit really hit the fan. 1 pound 14 ounces for all of this. So that's the charger to the radio, the charger itself, plus an adapter, which I'm going to cut down on this. And I took out the flashlight because this has a built-in LED flashlight in it, so that will serve as my light. Camera I don't need. I'm not going to be recording my anything really. I'll be too busy to do that. And of course the radio, for obvious reasons. That's all I need. This plus a solar panel to go with this device to charge out in the field. Gorilla Comm going 10-10.